Yeah, welcome back to Introduction of Sets Part 3. Today we will study the problems related to Venn diagram, and that's are really practical problems and very useful in the aptitude portion of GATE exam also. So Venn diagram, I told you in the lecture 2, if we have two finite sets, if A and B are two finite sets. Finite set is very important word here. It means we know the cardinality of set. Means number of elements in this set are finite. We can count the number of elements. Finite sets. Then A union B is given as number of elements in A union B is given as number of elements in A, or you can say the cardinality of A union B is equal to cardinality of set A plus cardinality of set B minus cardinality of A intersection B. If you see the Venn diagram for these two sets, this is your universal set, this is your set A, and this is your set B. If you take the A union B, then A union B is the portion. And if you add A and if you add B, so you can see that actually you are adding A intersection B part twice. So for balancing, you have to subtract one time because in A and B already you have added A intersection B part. So this is the formula for the number of elements in the set A union B. I have discussed this formula in lecture 2. Now, if there is a remark also, A and B are disjoint set. What is the definition of disjoint sets? I told you when the intersection of sets is a null set, the sets are said to be disjoint set. Then the cardinality of A intersection B will be equal to the cardinality of null set. And I told you the cardinality of null set is 0 because there is a no element in the null set. In this case, if you want to make the Venn diagram, this is your universal set, A and B will be disjoint, means there will be no portion common. In that case, the above formula will look like now number of elements in A union B equal to number of elements in A plus number of elements in B, because this term in this case is going to be 0. Similarly, this formula can be generalized for 3 and more sets. If A, B and C are 3 finite sets, then number of elements in A union B union C is equal to number of elements in A plus number of elements in B plus number of elements in C minus number of elements in A intersection B minus number of elements in B intersection C minus number of elements in C intersection A plus number of elements in A intersection B intersection C. This is for 3 sets. In this case, you can draw the Venn diagram like this. This is your universal set. This is set A, this is set B, and this is set C I am taking here. So A union B union C, if you see, in A union B union C, if you are adding A, it means you are taking A intersection B part, A intersection C part, and A intersection B intersection C part also here. Similarly, if you add for B and C, so for adjustment, you have to subtract these terms. You can see by drawing by yourself only. This is a very simple. By coloring and erasing in the Venn diagram, you can verify this formula. Similar remark, if A, B and C are disjoint sets to each other, then intersection parts going to be 0, or empty set, you can say that number of elements is going to be 0. So in this case, your formula will be turned out number of elements in A union B union C equal to number of elements in A plus number of elements in B plus number of elements in C. In this case, if you want to draw the Venn diagram, this will look like this is your A, this is your B, and this is your C. So these are two basic formulas, and I also told you in the previous lecture what is the De Morgan's law. I'm going to revise again because it will be useful here. De Morgan's law, I told you A union B complementary is equal to A complement intersection B complement, and A intersection B complement A complement union B complement. I told you. And if E is any set in the universal set, then E complement is defined as universal set minus E. I told you in the definition of complementary set in lecture 1. So you can see that the Venn diagram for this, if this is your E set and this is your universal set, so outside portion is going to be E complement. If you replace E, here by some A intersection B, you can say that if you take the cardinality also, formula will look like this: number of elements in the universal set minus number of elements in the given set. So if you replace E by A intersection B, so A intersection B complement will be equal to the number of U minus number of element in A intersection B. You can replace E by any of the operation here. E can be A union B, A intersection B. For suitable substitution, I am taking here E. E is any general set. It can be union or intersection of some other finite sets. So let's see some example based on this. In a school, there are 20 teachers. In a school, there are 20 teachers who teach mathematics, maths, or physics. Of these, 12 teach maths only, maths, 12 teach maths, not only word here, and 4 teach both physics and maths. How many teach physics? How many teachers teach physics? You can see that I am taking here two sets, A physics and math. If you draw the picture here, always draw intersection part firstly. This is your universal set, this is your math set, and this is your physics set. You can see that 4 teach both. It means this is the intersection part. So 4 we will put here. Now, if you see 12 teach math. 12 teach math, it means 4 already included in math portion. So 8 will be here because there are total 12 teachers are teaching mathematics. Out of 12, 4 teachers are teaching math and physics both. So remaining 8 teachers are teaching only mathematics. There are 20 teachers. So there are total 20 teachers, 8 for 12 already included. So here if you see, there will be 8 teachers in physics only. Then only 8 plus 4 plus 12 will be 20. This is the simple way using Venn diagram. You can see that number of teachers are teaching physics are now. Physics teacher are 4 plus 8 equal to 12 here. Because 8 are the only physics teaching physics only and 4 are teaching both. But by the formula if you see, suppose this is your math and this is your physics, then math union physics is number of element in math, number of element in physics minus number of element math intersection physics. So union means teaching math or physics. I told you the definition. If any element is belonging to M union P, math or physics, the definition is X is belonging to M and X are belonging to P. It means teaching math or teaching physics or. So this is 20 given in the question. Number of teachers teaching math is 12 here. Number of teachers teaching physics I have to calculate. Number of teachers teaching both are 4. So if you solve, you will get number of teachers teaching physics. There will be 12 only. So this is the method to calculate by the formula, and this is the way by Venn diagram you can solve this problem. Next problem is, in a survey of 400 students, 100 were listed as taking apple juice, 150 are taking orange juice, and 75 are listed as taking both apple and orange juice. Find how many students were taking neither apple nor orange juice, not orange juice. See the problem. We are interested. Firstly, I am going to solve this using Venn diagram. Then I will solve using the formula. See the Venn diagram. There are two events here, apple juice and orange juice. Suppose this is your apple juice circle and this is your orange juice circle. So firstly, we have to fill the common student. So if you see, there are 75 students which are common taking both apple and orange. Now see the number of students who are taking apple juice. 100 are taking apple juice. Out of 75 taking orange also. So remaining 25 students, only 25 students are taking apple juice. Only means they are not taking orange. But total, if you see, there will be 100 because 100 students are taking apple juice here. Now, if you see the orange juice, 150 are taking orange juice, 75 is common, then left will be 75 here. So these students are taking either apple or orange. So if you add these numbers, you will see that the number of students taking apple or orange are here. 25 plus 75 plus 75 will be 175. In the universal, if you said, there are 400 students in the college. So outside this, which are not taking any juice, neither apple nor orange, will be equal to the total elements in the universal set minus either taking apple or orange. It will be 225. So this is the first way to tackle this problem. Similarly, we can solve it. So if you use the formula here, you can see that you want neither apple nor orange, means intersection portion, neither apple nor orange. The student who are taking neither apple nor orange. See the question carefully. Nor matlab and here. So if you use the De Morgan theorem, it will be equal to A union orange complement. If you use the De Morgan theorem, now I am calling it is as E element, E set. So E complement, I told you the formula. This is equal to number of elements in the universal set minus number of elements in the E. So it will be equal to the number of element in universal set minus number of element A union orange. So it is Number of element in universal set, use the formula number of apple plus number of orange minus number of apple intersection orange. This is 400 minus apple students are 100 here, orange are 150, both are 75. If you solve, you will get again 225. So this is the second way to tackle this problem. Now I'm going to discuss a third problem for 3 sets, and this is the last problem from my side in the set theory. A college awarded 38 medals in football, 15 in basketball, and 20 in cricket. There are 3 sets here: football, basketball, and cricket. If these medals went to total 38 men and only 3 men got medals in all the 3 sports, how many received medals in exactly 2 of the 3 sports? Very interesting problem. Firstly, I am going to solve it by the formula, then using the Venn diagram. Number of elements in football, union basketball, union cricket is equal to the number of elements in football plus basketball plus cricket minus intersection in football, intersection basketball minus football intersection cricket minus basketball intersection cricket plus intersection of all the football, basketball and cricket. Total medals are given to the 38 men. In the football, there are 20. In the basketball, there are 38 medal in football actually. Okay, there is a correction actually in the question. 58 men. There are 58 men. So this is your 58. 38 in football plus 20 in basketball minus plus uh, 15 in basketball and 20 in cricket. Yes. Minus plus if you add all the 3 in the all the 3 sport minus F intersection B plus F intersection C plus B intersection C. These are the number the medals received in exactly 2 games. You can see that football and basketball, football and cricket, basketball and cricket. This value we have to obtain. This is the question asked. So it will be football intersection basketball plus football intersection cricket plus basketball in the cricket is equal to 38 plus 15 plus 20 plus 3 minus 58. So it will be, I think, 18. So 18 medals are received in exactly 2 sports: football or cricket, football or basketball, cricket or basketball. Now, the next is using Venn diagram to solve this problem. This is your football, this is your basketball, this is your cricket. There are 3, and you don't know the number here, so you have to use A, B, C, D. You have to let here A, B, C, D, and many unknowns you will get. So by formula you are seeing, you can see that this problem is easy. Otherwise you have to suppose here A, B, then this value will be, there are total 38 now. So 35 minus A plus B in the football. Similarly you have to solve for basketball and cricket this problem. Now I'm going to tell you the exercise here. The exercise is very easy. I'm giving you some questions related to this chapter set theory. So you all can follow this, and this is the assignment for you. Okay. So these are the assignment. This is the first assignment for set theory 1.1. How to define a set. This is the exercise related to set representation, set builder form, roster form. This is based on the types of sets. This exercise is based on subsets. This exercise is based on the properties and operations on the sets. This exercise is based on the complementary of a set and the problem related to Venn diagram. This exercise is related to the problems today I have discussed. This is miscellaneous exercise for the chapter 1. All the theory we have discussed in the part 1, part 2 and part 3 lectures. Okay, one more exercise I am giving you here. I missed, I think. Okay. This is the next exercise related to three sets property I have discussed today only. These are the problems based on three sets. You all can try, and if you have any doubt, you can ask in the group. Okay, thank you.